Have you ever come face to face with a slow loading website? Of course, you would have. No one, I repeat, no one on this planet has been spared the privilege of waiting for a web page to load. Nothing comes closer to testing your patience than a website that loads with the blazing speed of a tortoise. Slow and steady wins the race, they say. No, not in this case. If you build a web application and it loads with the speed of a dial-up connection, chances are that you have started buffering and your users are contemplating why they came to this website in the first place. You might be inclined to blame the internet service provider for the misfortune. But what if I tell you that the issue might be the JavaScript loading strategy of your application? While JavaScript loading strategies is a pretty important topic, it generally tends to fly a little bit under the radar. We don't usually pay a lot of attention to how script files are actually loaded into the browser. And even when we do think about it, we end up getting confused about which strategy to actually choose. Today is the last day of that confusion. What are you still waiting for? Press that subscribe button and also the bell icon. Trust me, you don't want to be missing any future videos on CS Tracker. This is Saurabh here, and today I'm going to explain how you can choose the correct JavaScript loading strategy for your application. Here's the first question you should ask. How are scripts loaded by the browser? When a browser starts loading a particular HTML file and comes across a script tag with some JavaScript code, it stops building the document object model, also known as DOM. The default setup makes the browser immediately execute the script. The same also happens in the case of external scripts that we add to our HTML using the script source tag. Now this might be totally fine for your requirements, but if you look closely, this approach can lead to a couple of problems. First problem, scripts don't see the DOM elements declared below them. Due to this, we cannot add any handler to the DOM elements declared below the script tag. To take an example, the hypothetical code inside script.js file cannot add a click event handler to the click me button in the HTML body. Second problem, if the script is bulky, which is often the case with modern JavaScript applications, it will block the page. The users won't be able to see the page content till the script is downloaded and executed. Coupled with a bad internet connection, this can lead to a horrible user experience. At this point, you might say that's enough talk about the problems, and we see your point. But then, how should we actually load the scripts? Well, the first problem where scripts can't see DOM elements below them has a simple workaround that's being used for ages. Basically, we can simply put the script at the bottom of the HTML document just above the closing body tag. The script can now see the button element. And also, it solves the second problem to a large extent. Since the script is now at the end of the document, it doesn't block the page content from showing up before the script is actually loaded in the browser. So, not a horribly bad user experience. Let's celebrate, shall we? Not so fast. While our issues are somewhat solved, this approach leads to another problem. What if the HTML document is rather large? In such a case, there may be a significant delay in loading it, and only after loading the full HTML document, the browser will see the script and start downloading it. If the script is also bulky, it means an even bigger delay. Even though the page might be visible to the user, there is not much the user can do. Scripts add life to a web page. Until the point the script is not executed, it is basically a dead page. What then is the ideal solution? Modern browsers support a couple of script attributes that can help us choose the right solution for our requirement. These attributes are known as defer and async. Let's look at them one by one. The defer attribute instructs the browser not to wait for the script to execute. On finding a script tag with defer attribute, the browser will continue to process the HTML and build the DOM. Also, the script continues loading in the background. Once the DOM is fully built, then the script is immediately executed. This is how it looks in practice. The browser is happily parsing the HTML and building the DOM. It finds the script tag. At that point, it starts the script download without stopping the process of building the DOM. The script download may finish at some point, but only after the DOM is completely built the browser will execute the script. Some key takeaways of defer. Number 1. Defer is a Boolean attribute. Having it with the script tag means true, not having it means false. Second, defer is only applicable for external script files. You can't use it with inline JavaScript code within the script tag. Point number 3. Script tag with defer never blocks the page, so users will still see the page being rendered as the browser builds the DOM. Lastly, when there are multiple scripts and all of them use defer, they will be downloaded in parallel but executed in order. So if there are two scripts, script 1 and script 2, and script 2 gets downloaded earlier, it will still wait and will run only after script 1 is downloaded and executed. This is important because many times we load a JavaScript library and then we have our own script that depends on the library. In that case, we would want the library to be executed first. The next JavaScript loading strategy is using the async attribute. To define a script as async, we simply have to add the attribute to the script tag. Now async is a lot similar to defer. Just like defer, it also makes the script download non-blocking. In other words, browsers will continue to download the scripts when the DOM is being loaded. But async has a fundamental difference from defer. Basically, async scripts are completely independent. As soon as they finish downloading, the browser starts executing them. At this point, the browser will stop processing the HTML document. In other words, potentially blocking the building of the DOM. Now you might consider this as a bad thing, but it all depends on the use case. Async scripts are ideal for background processing or third-party functionality that does not depend on other parts of the application. Think about Google Ad Links or Google Analytics or any other process that can safely run without depending on the DOM. For such scripts, we should use the async attribute. Some key takeaways from async. First, async is also a Boolean attribute. Absence of async means async attribute is false. Second, the async attribute is applicable only for external scripts, just like defer. Third, async scripts are independent. Browsers don't block execution of async scripts, but async scripts can block the DOM building once they are downloaded. Lastly, in the case of multiple scripts, they don't wait for other scripts, and other scripts also don't wait for the async scripts. Now there is one small point that needs discussion. What if we use async and defer together? And yes, we can do that by adding both attributes to the script tag. So what does the browser choose in this particular case? On modern browsers, async gets the preference. But on older browsers that don't support async, the script follows the defer approach. This begs for some caution. Async and defer should be used together only when your application can work with the async approach of loading the script files. In other words, independent scripts. That was all about script loading strategies. If this video was helpful, please do like and comment. Also, do consider sharing it with friends or colleagues. And of course, subscribe to the channel and don't forget to press the bell icon. See you until the next video and